this is your introduction to chemical equations. So just some wording. When we say chemical formula, we mean this. And when we say chemical equation, we mean this. So a chemical equation shows a reaction. We do use chemical equations to show a physical reaction like a phase change, but most of them involve a chemical reaction where we're actually changing substances. So just basic stuff. Reactants are always before the arrow. Products are after the arrow. We can read the arrow as meaning yields or reacts to form. So, and also this over the arrow is a catalyst. We can put a catalyst over or under the arrow. Sometimes we have several things there. This symbol means heat. And so if we had heat in this one, we might put it down here. This does not mean that the reaction gives off heat. It means that you add heat or heat the reactants in order to make the reaction go, in order to make it react at a fast enough rate or whatever. So the last thing is these numbers in front are called coefficients. And they're very important because they give you the amounts that react or form. In other words, in this reaction, I have 2 molecules of H2 reacting with 1 molecule of O2. And we're going to be using these coefficients, there's a 1 there, in a lot of calculations. Let's look at why we need coefficients as far as what they do for us and how they are needed to explain what's happening. Anyway, so here's the top reaction, and this is a real chemical reaction that when hydrogen burns, burning means it's combining with oxygen, it forms water, and that's a real known reaction. On this one, I left all the coefficients off, and so what's wrong with the way that it's written there? It looks like we're losing an oxygen atom. We started with 2 and then our product only had 1. In a chemical reaction, you do not gain or lose atoms. That can happen in a nuclear reaction, but not in a chemical reaction. Sometimes it's helpful to draw what's happening and what's represented. Because we need to make sure we understand, what the formula means, but also what the coefficients are going to mean. So here we can see we have 2 oxygen atoms and we don't have 2 in the product. So let's go ahead and put the coefficients in here that balance this. Okay, and let's do another drawing. So there, I have all of the atoms drawn, and what I like about doing this, if you look at these, is that it really shows you the difference between what a subscript means. It's showing how many hydrogens on each molecule, and what a coefficient means. The coefficient tells us how many molecules there are. A skill that we sometimes learn is balancing a chemical equation, which means deciding what the coefficients would be. If you're given the reaction, what's happening, deciding what to put in front. And let's just look at this one and what somebody might do. They might see, so we look at the reactants versus the products, and we see that we have 2 hydrogen atoms before the reaction and 2 hydrogen atoms after. But then we see that in the reactants we have 2 oxygen atoms, and in the products we just have 1. So what people sometimes try to do is just put a 2 there. And what's wrong with that? Well, changing the subscripts, these subscripts, changes what the substances are. H2O is water, H2O2 is hydrogen peroxide. And we know, we were told that hydrogen combining with oxygen makes water. That's the product. So we don't want to change subscripts. We only want to change the numbers in front. And so how we did this one, again, we look at everything before the arrow and everything after and make sure we're not losing any atoms. And hydrogen looks balanced, so I look at oxygen. There are 2 here and only 1 here, so I would put a 2 there. And that just affected hydrogen. Now I have 4 hydrogens, so the coefficient multiplies. There are 4 hydrogen atoms represented, so I need to add a 2 here so that the reactant side has 2 hydrogens as well. So that's the main thing, or the biggest rule, is to only change coefficients. Do not change the subscripts. Also, you know, sometimes when you're balancing equations, you kind of get going in a cycle where you can't get things balanced. If that happens, what I suggest you do is just erase all the ones you have and start over, and it helps if you start from a different element. But if you look for these 2 little rules, if you look for elements that are only in one place on each side, in other words, sometimes you have 2 products that both have oxygen, it makes oxygen hard to balance. So don't start with an element like that. Start with elements that only occur one place on each side of the equation. And the other thing is, if you see an element that is by itself somewhere, and by itself, I mean not in a compound, that's a good one to leave for last, because if you put a coefficient in front of it, it won't change anything else you've already done.